Today we are going to talk about maxima and minima. We are going to define the local maximum of a function f of x to be a point where the function is maximum around that region. For instance, if we look at this point, you can see that in the region, let's say from here to here, the function is maximum here. This is called local maximum. The same way we can define a local minimum, for instance, a point like this point here. In this region, you can see that this point is going to be the minimum of the function. Now, the reason we call them local is that if you look at the big picture, and if we define the domain to be from A to B, you can see that this local maximum is lower than what we call an absolute maximum. This means that the function is maximum at this point in the domain A to B. So the function is having one point which is absolute maximum from A to B, and a local maximum like this point which is in this region. The function is maximum. The same way the function has, in this case, has an absolute maximum, which is the point which is circled here, and also has a local minimum, which is a point here, which is in this region. Algebraically, how we are going to find the local maximum? It's a very simple process. If you look at this local maximum here, you can see that f prime of x, which is the first derivative representing the slope is positive here, then it becomes 0 on the top, and then it becomes negative. So if we find the zeros of f prime, and if we check the sign of f prime to the left of that point and to the right, if to the left the sign of f prime is positive and to the right the sign is negative, then we know that this point is a local maximum. For a local minimum like this point, you can see that the slope here is negative, then it becomes 0, then it becomes positive. So algebraically, again, we have to find f prime. You make it equal to 0, then we have to find the roots or the zeros of f prime, and then any one of these points, if the sign of f prime is negative to the left of the point and it's positive to the right of the point, then that point is a local minimum. Now, to find the absolute maximum or minimum, if a function is given with the domain, let's say A and B, then what we have to do is to find the zeros of f prime, and then we have to evaluate the function, not the f prime anymore, the function at the zeros of f prime and also at the endpoints, and then compare all these values. The one which is the highest is the absolute maximum, and the one which is the lowest is the absolute minimum. The first example is to consider the graph to the right here, this graph, from 0 to 10. We have to identify the local maximum points here. The local maximums can be this point or this point. Let's call it A and B. So these are the local maximum. Let's identify the local minimum. The local minimum, the only one we have is this point, which we call point C. Now, what is common between all these 3 points is very simple, is that the tangent to the graph at these 3 points is horizontal or is parallel to x-axis, or we can say the slope at points A, C, B is 0. Now we have to find the absolute maximum and minimum values in the interval 0 to 10. As I said before, when you are trying to find the absolute maximum minimum, we have to find the points where the function has a derivative equal to 0. So points A, B, C are the candidate, and also we have to find the value of the function at the endpoints, which is here and here. We can see that if we call this point to be point D and this point to be point E, you can see that the absolute maximum here is point B, because it has the highest y value, which is equal to 8 approximately, and absolute minimum is point D, which is something like 3. That's the absolute minimum of the function. We are now going to define a couple more definitions. First, a critical number. A critical number is any x value for the function f of x where it makes either the derivative equal to 0 or the function is undefined for that value. So this means that if you have to find the critical number of any function f of x, we have to find f prime of x and make it equal to 0, and then we have to find the roots here. Or if f prime of x is going to be a rational function, we have to find the zeros of the denominators. Now, when we find all these critical numbers, we call the critical point to be a point like A. Remember, A is a critical number and f of A is the value of the function at point A. This ordered pair, we call it critical point. As I mentioned before, to find the absolute maximum and minimum value of a function given an interval, what we have to do is to find f prime of x, make it equal to 0, and then we have to find all the zeros of f prime. And also, we have to find the endpoints of the domain. So this means that if a function f of x is given and we have to find the absolute maximum minimum, we have to find f prime x, make it equal to 0. Let's assume that you get a, b, c. These are the roots of f prime equal to 0. And let's assume that the domain here is x between, let's say, m and n. Then to find the absolute maximum or minimum, we have to find f prime of a, f prime of b, f prime of c, and so forth. Also, we have to find f of n, f of m, and then compare these values together. The highest one is the absolute maximum, and the lowest one is the absolute minimum. The next example says find the absolute maximum and minimum of the function f of x is x cubed minus 12x minus 3 on the interval of x between 4 and negative 3. First, we need to find f prime of x, which is 3x squared minus 12. We make it equal to 0. So from here, I get x squared is 12 divided by 3, which is 4. So x is going to be plus or minus 2. So these are the two roots of the first derivative. Now I have to find f of 2. F of 2 is 2 exponent 3 minus 12 times 2 minus 3, which is going to give us 8 minus 24 minus 3, which is going to give us 8 minus 3 is 5. 5 minus 24 is equal to negative 19. So this point is 2 and negative 19. Then we have to find f of negative 2. F of negative 2 is going to become 13. So this point is negative 2 and 13. Then we have to find the value of the function at the endpoints. So f of negative 3 becomes 6. So this point is negative 3 and 6. And f of 4 becomes 13. So we say 4 and 13 is another point. Now, if you look at this point, this, and this, you can see that 13 is the highest value for the function. So we can say the maximum, absolute maximum, occurs at negative 213, 413. Negative 213, remember, it's a local maximum, and 413 is our endpoint. The absolute minimum is going to happen at negative 19. So we can say that at 2 negative 19, this is a local minimum or absolute minimum. The next question says the surface area of a cylindrical container is to be 100 square centimeter. Its volume is given by the function V is equal to 50r minus pi r cubed, where r represents the radius in centimeter of the cylinder. Find the maximum volume of the cylinder in each case. Radius cannot exceed 3 centimeters. So radius is between 3 and 0. To find the maximum, we have to find the zeros of the derivative of volume. So V prime is 50 minus 3 pi r squared. From here, we are going to make 50 minus 3 pi r squared equal to 0. So we get 50 minus 3 pi r squared is equal to 0, or r squared is 50 divided by 3 pi, or r is square root of 50 over 3 pi, which is about 2.3 centimeter. Now what we have to do is, because we are looking for maximum volume here, we have to find volume at 0 at the endpoints. So if r is 0, volume is 0. If r is 2.3, the volume becomes 50 times 2.3 minus pi times 2.3 cubed, which is approximately 76.8. And volume at the other endpoint, which is 3, it becomes 65.18. So you can see that the maximum when r is less than 3 is going to be 76.8 cubic centimeter. The next question says, what is the maximum volume if the radius cannot exceed 2 centimeter? So this case, our r is between 2 and 0. Remember in part A we found that r is about 2.3. So this means that this cannot be accepted because r is less than 2. So again we have to find the value of the volume at 0, which is 0, and also at the end point 2, which is 74.9. Obviously the maximum is 74.9 cubic centimeter. The next question says, for the cubic function defined by f of x is ax cubed plus bx squared plus cx plus d, find the relationship between a, b, c in each case. Also d. There are no extrema. This means that if I find f prime of x and make it equal to 0, there is no solution. So again, I'm going to find f prime of x, which is 3ax squared plus 2bx plus c equal to 0. Using quadratic formula, I'm going to find discriminant, which is going to be d, which is b squared, which is 2b squared, minus 4a, which is 3a, times c, which is 4b squared, and this one is negative 12ac. Now, we know that if we don't want to have any solution, this means that this 4b squared minus 12ac has to be less than 0. So 4b squared has to be less than 12ac, or b squared has to be less than 3ac if we divide by 4, or b has to be between square root of 3ac and negative square root of 3ac. The next part of the question says there are exactly two extrema. Remember, the equation that we found was 4b squared, the discriminant, minus 12ac. If we want exactly two extrema points, this one has to be greater than 0, so 4b squared has to be greater than 12ac, or b squared has to be greater than 3ac. This inequality has two answers. One is b has to be greater than square root of 3ac, or b has to be less than negative square root of 3ac. The next question says, for the quartic function defined by f of x equal to ax exponent 4 plus bx squared plus cx plus d, find the values of a, b, c, d such that there is a local maximum at 0, negative 6, and local minimum at 1 and negative 8. This means that I have to find the first derivative of f of x. So f prime is 4ax cubed plus 2bx plus c. Now this has to be equal to a cubic function. Since our cubic function has a local maximum and a local minimum at x equal to 0, negative 6, 1 and negative 8, then it means that this cubic function that I got can be written as a constant, let's call it k, times x minus 0, because 0 is one of the roots of the derivative, and x equal to 1 is another one, so x minus 1. And since it is a cubic, let's say the third root is p, which is unknown. Now, if I expand this and simplify it, I'm going to get kx cubed plus x squared times negative pk minus k plus pkx. You can just do it yourself and you will see that you will get exactly the same expression. Now, since the cubic on the left and cubic on the right are equal, all the like terms, they have to have the same coefficient. This means that k has to be equal to 4a. So that's the first observation. K is equal to 4a. The other observation is, since x squared on the right has a coefficient, but the left one doesn't have any coefficient, any term x squared. This means that minus pk minus k has to be 0. From here, we get k times minus p minus 1 is equal to 0. It's either k has to be 0 or p has to be negative 1. K cannot be equal to 0 because if k is 0, then we don't have any expression on the right. Because kx cubed is 0, pk minus k is going to give us 0, and pk also, pkx gives us 0. And that can be happening. So p has to be negative 1. That's the second observation here. The next one, we can see that pkx and 2bx, they are like terms. So this means pk, and remember p is negative 1, so negative k has to be equal to 2b. That's another observation. Now, I know that k is equal to 4a. So I can put it back here, so I get 2b is negative 4a. Or b is negative 2a. Also, you can see on the right this expression, there is no constant. So this means c has to be equal to 0. So c is equal to 0. So right now, I know what the value of a and b are related to each other. B is equal to negative 2a, and also c is equal to 0. So I can write that f of x is equal to ax4 plus bx squared. B is negative 2a, so negative 2ax squared plus cx. C is 0, so cx is 0 plus d. So this is my equation so far. To find a and d, I'm going to use these 2 points, 1 and 2. We know that when x is 0, y is, or f of x is negative 6. So negative 6. When a is 0, a times 0 is 0, minus 2a times 0 is 0, plus d. So d is negative 6. Also, so this means that f of x is equal to ax4 minus 2ax squared plus d, which is negative 6. Now we know that when x is 1, y is negative 8. So negative 8 is equal to a times 1 exponent 4 is a minus 2a minus 6, which is minus a minus 6. So from here, if I move negative 6 to the left, it becomes positive 6. Minus 8 plus 6 is negative 2. So I get negative a is negative 2, or a is equal to 2. So this means that our original equation, f of x, will become f of x is ax exponent 4, so it's 2x exponent 4 plus b. B, we know that is equal to negative 2a, so b becomes negative 2 times 2 is negative 4, so it's negative 4x squared, plus cx, c is equal to 0, so that term is gone, plus d is negative 6. So our equation is 2x exponent 4 minus 4x squared minus 6.